What if the universe we live in isn't the first? Could there have been another universe before ours? And even more mind-blowing, could there be evidence of another Big Bang at the edge of our universe? These questions aren't just science fiction. Any more recent research by a Nobel Laureate has uncovered what may be the first hint of another Big Bang, shaking the very foundations of modern cosmology. Stick around as we dive into this mind-bending discovery and explore what it could mean for our understanding of the universe itself. The Big Bang Theory is the most widely accepted explanation for the origin of the universe. It suggests that approximately 13.8 billion years ago, all matter and energy were concentrated in an incredibly hot and dense point known as a singularity. Then, in a massive explosion, the universe began expanding, cooling over time to form galaxies, stars, and planets. This theory explains much of what we observe today, including the cosmic microwave background radiation, the faint afterglow of the Big Bang, which permeates the universe. But what if this explosive event wasn't the first? What if we're just part of a cosmic cycle of Big Bangs and expansions? Enter the Nobel Laureate, who may have found the first evidence of another Big Bang. Through cutting-edge telescope observations and data analysis, this renowned scientist has detected unusual patterns at the farthest reaches of the universe. Specifically, in the cosmic microwave background radiation, there appear to be unexplained fluctuations that don't fit the current models of the universe's expansion. These fluctuations, some argue, could be the remnants of a previous universe, one that existed before ours and underwent its own Big Bang. While this is still a controversial and developing theory, it has already sparked intense debate within the scientific community. So, what exactly are we observing at the edge of the universe? The cosmic microwave background radiation offers a snapshot of the universe as it was roughly 380,000 years after the Big Bang. However, the recent observations by the Nobel laureates suggest that this radiation may carry imprints of events that occurred even before the Big Bang we know. Some scientists speculate that these imprints could be evidence of a previous universe collapsing and triggering the Big Bang of our own universe. If true, this would suggest that the universe might be cyclical, with periods of collapse followed by rebirth. If this theory of a previous Big Bang is confirmed, it could revolutionize our understanding of cosmology. The idea of a multiverse or cyclical universe has long been theorized, but hard evidence has remained elusive until now. This discovery could force scientists to rethink many aspects of the universe's origins and its ultimate fate. Instead of a one-time event, the Big Bang might be just one of many in an endless cycle of expansions and contractions. This could also impact theories about dark energy, dark matter, and the overall structure of the cosmos. The next steps in this research involve further observations and testing the theory against competing explanations. Astronomers and physicists are eagerly awaiting data from upcoming space missions, such as the James Webb Space Telescope, which could provide more detailed information about the early universe. In addition, new mathematical models are being developed to account for the possibility of multiple Big Bangs or a cyclical universe. While we are still in the early stages of this research, the potential for groundbreaking discoveries in the next few years is immense. Who knows, this might be the beginning of an entirely new chapter in our understanding of the cosmos. The cyclical universe theory, also known as the Big Bounce model, suggests that the universe goes through cycles of expansion and contraction. In this theory, our universe is just one phase in a never-ending series of Big Bangs, followed by eventual collapses known as Big Crunches. After each collapse, the universe bounces back in a new Big Bang. The idea has been around for decades, but it's always been theoretical. Now, with the Nobel laureates' observations, we may have the first concrete evidence that this theory could be more than just a fascinating idea. The anomalies observed in the cosmic microwave background radiation are small but significant. Scientists have noticed subtle temperature variations that don't fit the standard model of the universe. These fluctuations seem to suggest the presence of something beyond the Big Bang, we know perhaps the remnants of an earlier universe. While these anomalies could have other explanations, the possibility that they are signs of a previous Big Bang has captivated researchers. More detailed observations will be needed to confirm or refute this, but the data collected so far is compelling enough to take seriously. Another fascinating possibility that arises from this discovery is the multiverse theory, the idea that there are multiple, perhaps infinite, universes beyond our own. If the Nobel Laureate's discovery is linked to a previous Big Bang, it could lend credibility to the idea that our universe is just one of many. Each universe could have its own set of physical laws, dimensions, and even time frames. The multiverse theory could explain many unanswered questions in physics, such as why our universe appears to be fine-tuned for life. Could this be one of many universes, each with different conditions? Dark energy, a mysterious force that seems to drive the expansion of the universe, could also play a role in the cyclical model. In our current understanding, dark energy is causing the universe to expand at an accelerating rate. However, in a cyclical universe, dark energy might not just drive expansion, it could also trigger a collapse, leading to a new Big Bang. Understanding the interplay between dark energy and the cyclical universe model could be key to proving or disproving the idea of multiple Big Bangs. One of the biggest challenges in exploring these groundbreaking theories is the limitation of our current technology. While telescopes like the James Webb Space Telescope are incredibly advanced, they are still limited in how far they can peer into the universe's past. The farther we look, the closer we get to the cosmic horizon, beyond which we can't see because light from those areas hasn't reached us yet. However, new technologies, including gravitational wave detectors and quantum computing, may one day allow us to peer even further into the past and perhaps into other universes. If the cyclical universe model is correct, it could dramatically change our understanding of the universe's ultimate fate. Instead of an eventual heat death, where all energy in the universe is evenly spread out and no further reactions occur, we could face a big crunch. In this scenario, the universe would stop expanding and begin contracting, eventually collapsing in on itself. This would trigger a new Big Bang, creating a brand new universe. The thought that our universe is part of a cycle of death and rebirth is both exciting and daunting. We're still a long way from fully confirming the existence of a previous Big Bang, but we're closer than ever before. Over the next decade, scientists will be gathering more data from a variety of sources, including the James Webb Space Telescope and next-generation radio telescopes. These tools could help us look deeper into space and time, offering new insights into the cosmic microwave background radiation and other signals that might point to a previous universe. As we gather more data, we could be on the verge of a major breakthrough. Of course, not everyone is convinced that these anomalies in the cosmic microwave background point to a previous universe. Some scientists argue that these fluctuations could be explained by other phenomena, such as gravitational waves from massive black holes, or even errors in the data. Others believe that our understanding of the universe's structure is incomplete, and that the anomalies could be the result of some unknown process within our own universe. It's important to consider all possibilities as we work toward understanding these strange signals. If the universe is truly cyclical, it could have profound philosophical implications. What does it mean if time itself is part of an endless loop? Would each new universe be an exact replica of the last, or would each one be entirely unique? Could there be life in each cycle, or are we just a fleeting part of one phase in an infinite pattern? These are deep questions that science can't fully answer, but they certainly inspire us to think about our place in the cosmos in a new way. Quantum mechanics, the branch of physics that deals with the smallest particles in the universe, could offer clues about the Big Bang cycle. Some physicists believe that quantum effects could trigger the transition between different phases of the universe, causing a collapse and rebirth. Quantum fluctuations in space-time might be the mechanism that starts each new Big Bang. While this is still speculative, research into the quantum realm could help us understand how the universe behaves on the smallest possible scales, and how those behaviors might influence the cosmos as a whole. If a previous universe did exist, could we ever actually detect it? Some scientists believe that there might be physical remnants of a previous universe, such as black holes or gravitational waves, that have survived through the Big Bang. If we could detect these remnants, it would provide direct evidence of another universe before ours. Current technology isn't yet capable of such a discovery, but future advancements could change that. The search for these remnants is one of the most exciting frontiers in cosmology today. String theory, which suggests that all particles in the universe are made up of tiny, vibrating strings, and M-theory, a broader framework that includes multiple dimensions, could be impacted by the discovery of a previous Big Bang. Both of these theories already suggest the existence of multiple universes, or a multiverse, in which our universe is just one of many. If evidence of another Big Bang is confirmed, it could offer the first tangible support for these complex theories, helping to bring them from the realm of abstract mathematics into observable reality. If the cyclical universe theory is correct, and our universe is destined for a collapse, could humanity ever prevent it? While this might sound like science fiction, some scientists have speculated about ways to manipulate dark energy or other cosmic forces to either delay or prevent a big crunch. While we're far from having the technology to influence the fate of the universe, it's fascinating to consider the possibility that one day we might be able to play a role in shaping the future of the cosmos itself. If the universe is cyclical, what would life be like in another universe? Would intelligent life even exist in each new cycle? Or is our existence a rare fluke? The conditions in each new universe might be completely different. Gravity could be weaker, the speed of light could vary, or the laws of physics could change. It's possible that life, if it existed at all, would take forms that are completely unimaginable to us. While this is still speculative, it raises intriguing questions about the nature of life and the universe. The discovery of a potential previous Big Bang is just the beginning. The future of cosmology promises to be filled with exciting discoveries as new technologies allow us to explore deeper into space and time. Whether we confirm the existence of a cyclical universe or find another explanation for the anomalies in the cosmic microwave background, the next few decades could bring a revolution in our understanding of the cosmos. Whatever we find, it's clear that the universe is far more mysterious and complex than we ever imagined. Gravitational waves, ripples in space-time caused by massive cosmic events like black hole collisions, might provide crucial evidence in the search for previous universes. These waves can travel vast distances, carrying information from the earliest moments after the Big Bang. If we could detect a unique pattern in these waves, it might point to an event beyond our current universe, perhaps the collapse of a previous one. With advanced detectors like LIGO and Virgo, scientists are already studying gravitational waves, and their findings could open up new avenues for understanding the nature of the cosmos. The James Webb Space Telescope, launched to provide unprecedented insights into the early universe, is one of the most powerful tools at our disposal for exploring the Big Bang and beyond. Its advanced infrared capabilities allow it to peer deeper into space than ever before, potentially revealing ancient galaxies and cosmic phenomena that date back to the universe's infancy. If there are remnants of a previous universe, the telescope might detect them in the form of strange cosmic structures or unexpected radiation patterns. This cutting-edge technology is paving the way for groundbreaking discoveries in the coming years. One of the more speculative but fascinating ideas in cosmology is the notion that black holes might be gateways to other universes. According to some versions of the multiverse theory, a black hole in one universe could act as a bridge to another. As matter collapses into a black hole, it could pass through to a new universe, potentially triggering its own Big Bang. While this concept remains in the realm of theory, the study of black holes and their singularities might one day reveal hidden dimensions or connections between universes. Another tantalizing possibility in the cyclical universe theory is that time itself could be repeating. If our universe goes through an endless cycle of big bangs and big crunches, it raises the question, could we be living through the same sequence of events over and over again? Some scientists have even speculated that certain quantum processes might ensure that each new universe follows a similar pattern to the last, though with subtle variations. This could mean that everything happening now has happened before and might happen again in an infinite loop of time. Inflation theory, a key part of modern cosmology, proposes that the universe underwent a brief but rapid expansion right after the Big Bang. This inflation smoothed out the universe's structure and helped to explain why the cosmos looks the way it does today. However, if the cyclical universe theory holds true, inflation might not just occur once, it could happen repeatedly after each new Big Bang. Each cycle would begin with an inflationary period, followed by a slower expansion and eventual collapse. Understanding how inflation fits into a cyclical universe is one of the big challenges facing cosmologists today. The concept of time moving in one direction, often called the arrow of time, is something we take for granted. We experience time as a linear progression from the past to the future. But in a cyclical universe, the arrow of time could behave differently. Some theories suggest that time might reverse at the end of one universe and the beginning of another. If the arrow of time flips between cycles, it could mean that the fundamental nature of time changes at each Big Bang, leading to universes with entirely different time flows than our own. A key question in the cyclical universe theory is, what happens to matter when one universe ends and another begins? Does all matter get destroyed in the Big Crunch, only to be reformed in the next Big Bang? Or are there remnants of the previous universe that carry over? Some scientists speculate that certain elements, like black holes or dark matter, could survive the transition and be present in the next universe. If this is the case, it could help explain the mysterious nature of dark matter in our universe, which we still don't fully understand. Entropy, the measure of disorder in a system, increases over time in a closed system like the universe. As entropy rises, the universe becomes more disordered and less structured. In a cyclical universe, however, entropy might reset with each new Big Bang. This would mean that after the collapse of one universe, the next begins in a low entropy, highly ordered state. Understanding how entropy behaves in a cyclical model is a major question for physicists, and answering it could provide crucial insights into whether a cyclical universe is possible. The discovery of a previous Big Bang raises an interesting question. Could the universe be finite rather than infinite? In the standard model, the universe is constantly expanding and could go on doing so forever. However, if the universe is cyclical, it might have a finite size, with boundaries determined by the Big Crunch and the next Big Bang. This could mean that space-time itself is finite, looping back on itself at the end of each cycle. Such a discovery would fundamentally alter our understanding of the universe's shape and size. Dark matter, the invisible substance that makes up much of the universe's mass, could play a crucial role in the cyclical universe model. In our current understanding, dark matter influences the formation of galaxies and holds them together. But in a cyclical model, dark matter could also help drive the collapse of the universe. As dark matter interacts with normal matter, it could cause regions of the universe to contract, eventually leading to a Big Crunch. Exploring the role of dark matter in the context of a cyclical universe could help answer one of the biggest mysteries in modern astrophysics. Proving the cyclical universe theory would require more than just observation. It would demand new ways of thinking about physics. Scientists would need to find a signature of a previous universe, such as unusual gravitational waves or cosmic radiation patterns that can't be explained by current models. In addition, new mathematical frameworks would be necessary to describe how one universe collapses and another begins. The challenge is enormous, but with advances in technology and theoretical physics, we might one day be able to prove or disprove this bold idea. One of the biggest gaps in our understanding of the universe is how gravity behaves on a quantum level. Quantum gravity, which seeks to unify general relativity, the theory of large-scale gravity, with quantum mechanics, the theory of particles on the smallest scales, could be key to understanding the Big Bang cycle. Some physicists believe that quantum gravity could explain how space and time behave at the moment of the Big Crunch and the subsequent Big Bang. Understanding quantum gravity might be the key to unlocking the mysteries of the cyclical universe. While the discovery of a possible previous Big Bang is exciting, we must also consider the possibility that our universe is the first and only one. In this scenario, the anomalies in the cosmic microwave background might be due to other, more mundane phenomena, such as dark energy or unknown forces within our universe. If our universe is the first, it raises deep questions about how and why the Big Bang occurred in the first place. Could the universe have sprung into existence from nothing, or was there a cause that we have yet to understand? If the theory of a previous Big Bang is proven, it will have far-reaching implications for physics. We would need to rewrite our understanding of the universe's origins, its structure, and its ultimate fate. The discovery of a cyclical universe would also impact fields like quantum mechanics, cosmology, and even philosophy, forcing us to reconsider the nature of existence itself. It could also open up new fields of study as scientists begin to explore the possibilities of multiple universes and how they interact with one another. On a personal level, the discovery of a previous Big Bang might make us rethink our place in the universe. If the universe is part of a cycle of birth, death, and rebirth, what does that mean for humanity? Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.